Good afternoon, everyone. Hopefully you can hear us and everything is going okay. I just wanted to thank you for joining us for today's webinar on underlayments for marine applications. We have some brief housekeeping before we start. Your phones are on mute, so if you have any questions, please type them into the Q&A box in the corner of your screen and we will answer them at the end of today's session or via email after. And you can always send questions to mapeadigital@mapei.com. We also invite you to visit the Products for the Marine Industry page of our website on www.mapei.us, which contains system solutions, real-life case studies, brochures, and more. Now, without further delay, I'd like to introduce today's speakers, Mike Daniels and Guido Sardi. Mike Daniels is the Technical Service Manager for MAPEI's Marine Division. He has 28 years of experience at MAPEI Corporation and a total of 35 years of experience in the construction industry. This experience includes technical assistance, product training for marine markets, small and large-scale physical, structural testing for building systems, construction of building assemblies, product formulation and quality control in the United States, Caribbean, and South America. He is currently responsible for on-site product support, product recommendations, and performing product training on the installation of underlayments, flooring systems related to marine applications, and the evaluation of new products or systems in development. Mike is an active ASTM, FO6, and C21 committee member. Guido Sardi is the Business Development Manager for MAPEI's U.S. Marine Division, and he's responsible for the market share and new product development. He joined MAPEI in 2016, bringing his 20 years of experience in the marine industry to help foster the growth of MAPEI's marine line of products. His experience in the marine industry includes international sales for various sectors, ranging from pumps for hulls and engines to resin floorings. Guido also has experience in consulting gained through his work with the Italian Research and Consultancy Center owned by Fincantieri, one of the world's foremost cruise ship builders. I welcome them to the microphone. Mike and Guido, the floor is yours.
Good afternoon. I'm Mike Daniels with MAPEI, and today we're going to be covering exactly what are underlayments for marine applications. MAPEI has a specific line of products for the marine business. So without further ado, let's talk a little bit about these things. MAPEI is not really new to the marine business. It's been selling self-leveling materials, patches, and adhesives, and other supporting products for many years to this business. MAPEI realized that the marine environment is different from land-based installation of underlayment materials. The large variety of marine vessels that require solutions for underlayments were created to address the unique environment of a marine vessel. For this presentation, we'll focus largely on underlayments used on cruise ships, but most of the products discussed are used for many other varieties of ships, including cargo, tankers, military offshore platforms, tugboats, support craft, mega yachts, yachts, and recreational boats, just to name a few. We're going to cover a few topics in this presentation. The first one is, what are the requirements for a product to be used on the ship? The second, what's the importance of having specifically designed and created products for ships? And then thirdly, we're going to finish by talking about what are the features and advantages of MAPEI, our marine line of products. So first of all, why is it important to use an underlayment when installing flooring on a ship? Well, let's start with the definition of an underlayment. An underlayment is a material or product intended to support the underside of a floor covering or finish and smooth or fill the unevenness in a floor prior to the installation. Now, you're probably wondering about the two lines that are in the frame you're looking at. One of them is straight line and one of them has kind of a squiggly look to it. Can you guess which one is longer? Now, the thinkers of you might think about this and go, well, you know, they're the same length. Or You know what, maybe the squiggly one's a little bit longer. And if you think the squiggly one is longer, you're actually right. Because when we have an uneven surface, the actual distance that the flooring has to travel over that surface is longer than if it's flat. So what happens is we get some unevenness in the floor. And when we do our layout of our flooring, which is modular, we start to see the joints vary. We start to see things that are kind of unsightly looking. Addition to that, we actually can, in some cases, have issues with people where they're not picking up their feet and they trip or they fall. So what we're trying to do in using an underlayment is flatten the floor. Now, an additional benefit to flattening the floor is we use less adhesive also. So let's take a look a little bit more. Now, all floors have some degree of unevenness, and we know this. And the best way to look at this highs and lows is to know that, first of all, it doesn't follow a specific pattern. Now, you're going to look over here and you're going to see a diagram. Now, the diagram basically is a topographical map. And unevenness in floors often looks like this. We get highs and lows, and there's really no pattern. Now, what we do with an underlayment is we try to fill these uneven spots and support the flooring system that's going to be installed. Now, we also have to think about the environment where the floor is to be installed, as well as the traffic. So we're considering why is it important. Now, the next thing to consider is how marine underlayments differ from regular flooring underlayments. Now, ships are not exactly like your land-based jobs. There's a lot of forces that can make the ship flex and vibrate. There was an article written by Aisha Khan in 2017 that described the forces on the ship like a continuous earthquake that sends vibrations through the structure of the ship. Consider whatever product we put on that deck has to be flexible and strong and resist the forces. Now, if you'll look at the picture, you'll see the Seven Seas Explorer atrium chandelier. Well, that has to be pretty strong to survive all of that vibration and movement. And then on the right, you're going to see the Celebrity Cruises wine tower that suspends 2,000 bottles of wine and uses gyroscopic stabilization to keep these bottles from clinking into each other and breaking. Because the ship is moving so much, you really don't want those bottles vibrating too much also. Now, one of the things that you should be thinking about right now is that it's not a matter of if, it's how much. It's that the ship will bend, vibrate, and twist torsionally as the ship's moving. Now, what causes this? Simply the weight of the ship, wind, currents, propulsion, passenger load, equipment. How about the supply load? And then you have to consider the navigated course. In other words, we're going through different areas of the world with different currents. So the ship is constantly in a state of movement. The products that we put on these decks, they've got to be stuck and they cannot crack or lose bond. Now, another thing that we have to consider in marine environment is the lightweight materials. Now, we don't really think about it on our houses. We don't think about weight. But on a ship, weight is very important. So the dead weight of the finishes and their location on the ship has an impact. Some ships will have decks 13 stories above the waterline. That represents a lot of weight up high. If you reduce the weight of the finishes up in those higher decks, you're actually going to reduce the inertial mass and actually make the ship more stable when you're navigating, when the ship is moving, when it's plotting its course. Also, another feature and benefit of the lighter weight materials is that you're going to save on fuel because you're reducing the weight sitting on that ship. Now, I'm going to give you an example to think about here. If we were to use a lightweight screed product and a tile mortar in a cruise ship's galley, using a lightweight product like the MAPEIUSA Marine 1000 at about 1.25 inches thick. Now, let's consider this in a galley of about 2,500 square feet. Now, while it might seem big to you, 2,500 square feet in a galley is not really that big of a galley on a cruise ship. Now, how much weight savings do you think we're going to gain here? Well, we actually calculated the weight savings of about 6,800 pounds just by using the lightweight screed, which is about 3,084 kilograms. Now, if we add to that using a lightweight mortar to install the tiles, like our Ultralight S1, you're gonna actually take another 1,136 pounds or 515 kilograms of weight off the weight of the ship. Now, together, that will really reduce the ship's load by 8,000 pounds or 4 US tons. Consider that that's quite a lot less load that the ship has to carry around, resulting in better fuel economy and better stability. Another difference is that these ships all navigate in salt water. And if you're looking at the pictures, you're noticing every one of these pieces of metal is rusty. Now, they didn't start out rusty, but it doesn't take but maybe a day for the steel to rust when it's exposed to salt air, which is quite corrosive. Now, we think salt air, when we go to the beach, we think, yeah, that's great for my skin. But any exposed metal will corrode super fast in this environment. All the materials that we use over these decks have to be designed in such a way that they're resistant to this corrosive environment and will not deteriorate. We even have some products that are designed specifically to protect the structure of the ship from exposure to this corrosive environment. Consider that the ship is a floating hotel, and it's also regularly sanitized. So some of the chemicals we use to sanitize the ship are also pretty strong. The next thing to consider is what exactly fire resistance. Well, in our homes, in our offices, we don't consider fire resistance as super important. Now, in commercial structures, we think about it more, but they have to be certified resistant to fire and not generate toxic fumes if they're burned. Now, all of these products are considered primary deck coatings. Also consider that the ship is one steel box designed to keep water out, which means that if you have a fire inside, it's not a good place to be. So what we do is we actually certify these products. We certify the products to meet a certain standard. Now, the certification is done by the United Nations, who is responsible for SOLAS, or Safety of Life at Sea. And this includes all ships navigating our world. There's an international treaty that the United Nations manages. They regulate the body called the International Maritime Organization. And they organize and they establish a group of performance and safety criteria for systems and products used on the ship. The interior and exterior finishes are called primary deck coverings and are regulated by this code. MAPEI products made in the US and internationally are designed to meet the demanding engineering requirements on a ship, as well as you'll notice that on our data sheets and on our packaging, a wheel mark. It looks like a little steering wheel of a ship. And that certifies that they were tested for fire resistance and smoke generation, which you'll see is Module B in the IMO code. We're also independently certified at the plant level through a series of inspections that validate the product and quality and consistency of manufacturing. This IMO MED type approval is performed by independent organizations. In the case of MAPEI products, we use RINA, which is in Italy. But there are also other organizations you may be familiar with, like Lloyd's or the US Coast Guard. Less familiar, the ABS, or the US American Bureau of Shipping, or DNVGL, which is in Norway. And there's other ones in China and Japan and other places in the world that do independent certification to these codes. But remember, these are all independent certifications to an international code. Now that we've thought about all these different criteria, we really realize that the stuff on the land is really not appropriate. So how do we choose the correct underlayment? What exactly do we need to look at? Well, if you look on the ship, you're going to notice there's a lot of different areas on the ship that require underlayment. We've got public areas, you've got spa areas, you have passenger cabins and galleys, internal crew areas. You have sports areas with sports flooring, water parks. You have children's play areas and open deck areas where people stroll and walk. And then you have swimming pools. So everywhere that you see, there's different types of flooring. So in the public areas, you might see marble and wood and carpet. Whereas on the open decks in the sports areas and those other areas, you might see anything from tile to resin decking. So what exactly are the underlayments we need? Well, we talk about the underlayments in terms of their composition. We have cementitious self-leveling underlays, which are basically cement-based self-leveling materials, very similar to what we use on land-based jobs. They're used primarily in internal areas, under ceramic, tile, stone, carpet, vinyl, and wood. And then you have cementitious screed mortar underlays, which are products that are actually applied and can be pitched and used underneath primarily tile and stone. And the third category is actually resin underlayments, which consist of either a polyurethane or an epoxy-based material. And they can be either self-leveling or they can be thick and thixotropic, meaning that they will actually hold a specific angle or pitch as we apply it. And those are typically applied underneath resin floorings, underneath tile, underneath sports flooring. Sometimes you'll find it underneath safety flooring and other types of flooring that are necessary in those areas. So what are cement-based products? Let's start out with the self-leveling underlayments. You'll notice that we have the Ultraplan Marine 900, the Ultraplan Marine 1400, and the Ultraplan Marine Fire. Those are our three products that are available in this industry. The products below them, the Planibond EVA, MAPEI Code Guard 100, and Primer T are the priming systems used to bond these to the substrate. Now, the Ultraplan Marine 900 is a lightweight self-leveling underlayment. It has 0.9 kilograms per liter density. Now, if you're wondering what that means, a typical underlayment is about 2 kilograms per liter density, meaning it's half the weight. Now, we also have the Marine 1400, which is the Ultraplan Marine 1400 is a 1.4 kilogram per liter density. And the Marine Fire is a 2 kilogram per liter density. Now, each one of these products is fiber reinforced, rapid setting, and self-leveling. So when we talk about the priming systems, the Planibond EBA and the MAPEI Code Guard are both epoxy-based bonding agents used directly on the steel, whereas the Primer T will only go over existing cementitious underlayments that are in place. The difference between the two epoxy ones that you're seeing there, the EBA and the MAPEI Code Guard 100, is that MAPEI Code Guard 100 is designed to protect the steel from corrosion. So let's move on to the next part, and let's talk a little bit about what these underlayments actually do as their functions. Where do we use them? Now, the cementitious self-leveling underlayments are recommended for internal dry areas, such as common spaces, elevator lobbies, guest cabins, hallways, buffet serving areas, public bathrooms, and similar areas like that. So when we talk about the actual specific products, the Ultraplan Marine Fire and the Ultraplan Marine 1400 or 1400 are used in similar areas. They're used for similar applications, and they're recommended for any area under ceramic tile, stone, carpet, vinyl, or wood flooring. Because of their strength properties, they can be used in areas that will have heavy loads and heavy traffic. When you're trying to determine which one you want to use, when we're talking about weight savings, as we talked about before, the Ultraplan Marine 1400 is utilized when the designer or ship owner would like to incorporate weight savings into the underlayment and still needs load carrying capacity and the ability to carry heavy traffic. Now, the Ultraplan Marine 1400 has a 1.4 kilogram per liter weight. That means it's about 30% lighter than a conventional underlayment. Now, what that means to our installation is that for a 1,000 square meter or 10,786,000 square foot area, which is a common space size for a large dining area or a large restaurant area in a ship, if you apply it at 3/8 of an inch or 10 millimeters, this represents a weight savings of about 5 kilograms per square meter or 0.9 pounds per square foot. Well, Mike, that really doesn't make sense. Well, what does that mean to me? For this specific area, that means that you're saving about 4.8 US tons or 5 metric tons from the weight of the ship just by using the Ultraplan Marine 1400. That's significant, especially for some of these places that are sitting up on deck 13 or deck 14. Taking 5 tons off the ship can make the ship a lot more stable. So you ask, where do we use the Marine 900? The Ultraplan Marine 900 is recommended for areas that the designer again wants a lightweight material and they need to gain that lightweight, but they really don't have heavy traffic. So for example, in a guest cabin or crew cabins where they're trying to save some weight on the ship and they still have large areas to cover. For that same 1,000 square meters or 10,000 square feet or so, the weight savings are far more dramatic. You save 9.4 metric tons or 9.2 US tons. That's a lot. So we literally we've doubled our savings in weight by going to that underlayment. So the next part we're going to talk about is the screed mortars. What exactly is a screed mortar? Screed mortars are a mortar system that's actually designed to have a thixotropic property to it that you can compact into a specific thickness or shape. So it's particularly good at pitching areas or deep fills. So we can fill up to 2 inches thick or 5 centimeters on decks or other internal dry areas. It's also suitable for underneath ceramic tile, stone, and wood flooring. Now, having a specific weight of 1 kilogram per liter, which is half the weight of a typical screed mortar, and you're also doing a lot of weight savings. If you remember our earlier illustration for a 2,500 square foot gallery, the weight savings was about 6,800 pounds or 3,084 kilograms, just by using this product instead of the regular screed mortar, which also reduces the mass on the ship. Now you're looking at this MAPEIUSA Marine Hybrid. What is that? The Marine Hybrid is actually the same MAPEIUSA Marine 1000, but we modify it with a hybrid polymer component, which gives it additional strength and resistance to moisture. It helps us with exposure to intense traffic and wet areas. This also expands the use of the product into galleys, steam rooms, and other wet areas where ceramic and tile and stone are installed. And you'll notice that we're using the Planibond EBA in this one as well. The Planibond EBA is used as a bonding agent to bond this product directly to the steel. So the next thing we're going to do is we're going to move on to talking about the resin-based underlayments, which Guido will start to talk.
Thank you, Mike,
Guido?
I'm here. Thank you, Mike, for your great explanation about the cementitious underlays. Now let's move on with the last part of the presentation, which is the resin. Okay, now, first of all, talking about resin underlayments, we have to talk about the big difference between the polyurethane-based underlays and the epoxy-based underlays. These are the two main categories of resin underlays we can find on board. Let's start with the polyurethane-based underlays. We are talking about two components, self-leveling underlays, which are typically applied, can be applied both on internal and external areas. The application is done on board by pouring the material, so mixing the material on site, pouring them on the steel deck, and leveling it. And it's a seamless application. Therefore, both actually polyurethane and epoxies are good because they protect the steel deck against corrosion, because they create a seamless waterproofing surface that level the steel deck, as Mike was explaining before. The epoxy based is the same principle. Again, we are talking about two components, self-leveling underlays, which in this case are meant to be applied on internal areas only. Another big difference between epoxy and polyurethane underlays is that the epoxy are more heavy duty, more rigid compared to a polyurethane based underlays. And you will see in some examples I will show you later, mainly the epoxies are installed in crew areas, galley, storage rooms, in full epoxies systems. It's important to say something that sometimes customers are asking me, is it an epoxy because it's more rigid than a polyurethane breaking once it's installed on board? No, I can affirm that both polyurethane and epoxy-based resin are flexible enough to follow any steel deformation and ship movements without any breaking. As Mike said before, the ship is a piece of metal sailing and having deformation. When the underlays are applied in the proper way and there are not any defective application, they will never break. You will not have any detachment. Next, Mike. Okay, now let's go deeper into the underlays that we do manufacture as MAPEI. First of all, as Mike said, we always need a primer before starting with any underlay application. In this case, you'll see at the top of the page the MAPEI Primer 200, which is an adhesion promoter for polyurethane system, water-based, and the MAPEI Guard 100 that Mike explained already about, which is a multi-purpose epoxy coating with excellent anti-corrosion characteristics. The primers are applied directly on top of the steel after a suitable surface preparation. We do suggest a mechanical preparation at ST2 standard. After the application of the primer, we go with the application of the underlays. So the first 3 underlays, actually 4 you see, are all polyurethane based, and the last 2 on the page are epoxy. Let's start with the first one, which is the MAPEI light screed. This is a polyurethane, self-leveling, lightweight, self-extinguishing polyurethane-based layer, which levels internal and external bridge decks. The light screed is the product that we commonly use more on a resin job. Typically, most of all the open decks are leveled with this product. It's a lightweight. The density is 1 kiloliter. It's a 2-component on which we add a 3rd component, which is a filler that is used to make the product lighter and to build the thickness required. It's a certified IMO MED product and up to 20 millimeter. It has also a thixotropic version, which is called the MAPEI Light Screed Thixo. Why do we need a thixotropic underlay? We need it because in a case that I will show you later, I might be in need to level vertical metal deck of the ship. And in this case, I need a thixotropic underlayment, which will help me making, for example, a wall of a pool trunk very smooth and clean. Another underlay that we developed is the MAPEI Flexi Screed. This one, again, is a polyurethane bicomponent viscoelastic lightweight base layer for leveling internal and external bridge decks. I can say that it's a softer version of the light screed, and it has a specific use, meaning that compared to the light screed is more universal. We can use it on all the open decks or internal areas I need to level with the polyurethane underlay. The Flexi Screed is more devoted to those areas where I need to have a more flexible and viscoelastic material, such as sports areas, kids playground, and so on. The MAPEI Ultra Screed is a lighter version of the light screed and the Flexi Screed. As Mike made a good example about the self-leveling cementitious underlays we developed and the difference between the Marine Fire, the 1400, the 900. The Ultra Screed has a density of 0.7 kiloliter compared to the light screed that has 1. Meaning that I can go and use this product when I need to have a lighter underlay because, for example, I'm going to level a higher deck of a ship, or maybe in an application on a yacht or a mega yacht on which the use of light products is really required because it's every ship needs lighter weight, but especially yacht and mega yacht needs. Another advantage of this product is that it's pre-fillerized, so we don't have to add any additional inner material to it. Then we move to the epoxy underlays. We have the MAPEI EpoScreed Light and the MAPEI EpoScreed Super Light 070. Again, the first one, the MAPEI EpoScreed Light, is the state of the art of the epoxy underlays. It's a ready-mixed, low-density epoxy compound for leveling internal decks. There's a mistake in the slide. It's not suitable for external decks, actually. Where can I use the MAPEI EpoScreed Light? For example, on crew corridors galleys, on crew mess areas, on any technical areas on which, as I said before, we need a stronger material. Last but not least, the MAPEDEC Eposcrete Superlight 070. Again, it's a low density epoxy based material for leveling off internal surfaces, and it's the lighter version of the MAPEDEC Eposcrete Light. So same principle we said before for the Ultra Screed compared to the Light Screed. It's an epoxy underlay, which is lighter than the standard underlay, and I use it when I need when I have a specific request of lighter material. It's a product that, for example, we used also in the past in some military application. Next slide, Mike. Thank you. Now, to make it simple, I built the slides to show you in a very quick way some typical application of underlays on board of the ship. We start with the polyurethane. As I said before, this is a typical application of resin underlay on a jogging track or on a sport court. So as you can see from the listed material, we have an adhesion primer, which is the MAPEDEC Primer 200, followed by the MAPEDEC Flexi Screed, the viscoelastic polyurethane, on top of which we applied the MAPEDEC Soft Design, which is our polyurethane elastic soft top coat, followed by a sealer. In this case, this is a system that we call unofficially between us soft plus soft, because as you may see, I have a soft underlay on top of which I'm applying a soft top coat. Next slide. Thank you. This is a more traditional example of an open decks. Most of the open decks in resin material on a cruise ship, on a passenger ship, are done like this. We have an adhesion primer, in this case, the MAPECOT Guard 100. This is just an example, it can be done with the primer 200 I showed you in the previous slide. Followed by, in this case, the MAPEDEC Light Screed, which is the standard polyurethane self-leveling underlay plus filler. And then in this case, the top coat is represented by MAPEDEC Thick Design, which is our thick imitation, our version of thick imitation in polyurethane material. So in this case, it's not anymore a soft plus soft, as I said before. It's just a standard light screed plus the standard polyurethane resin top coat, finished with a sealer on top. Next. Okay, this again is an example applying what I explained to you about the MAPEDEC Ultra Screed. We are on a higher deck of a ship. The owner is requiring to have a lightweight system to save some kilos, some tons. And in this case, instead of applying the light screed, we have applied the MAPEDEC Ultra Screed. Again, we are talking about in this moment resin underlays most of the time, not all the time, but most of the time goes with a resin top coat. There are some hybrid systems. I will show you one example later, but in principle, when we talk about resin underlays, we go mainly with resin top coats because there's a perfect adhesion and perfect compatibility between all the layers. Next slide. And this is the case I wanted to show you that actually comes also from personal experience I had in the past. As you may see here, we have a MAPEDEC Light Screed on top of which we applied the turf with a suitable adhesive, which in this case is a polyurethane one. What happened in this case is that the need of the owner was, in my experience, the need of the owner was to level the steel deck and then go on top with the turf, which was originally applied, but it was applied on an open deck directly on the steel. So there was brick and valleys, and so peaks and valleys, sorry, and so it was not possible. So it was not duly leveled. And the advantage of applying the MAPEI light screed below a turf was also that after when the owner would decide the next dry dock to remove the turf, we have already the MAPEI light screed applied on on top of the steel deck, and this means that you can remove the turf, send existing light screed, and go, for example, on top with a resin top coat, like the thick imitation. So this shows you also the versatility of a polyurethane underlay applied on an open deck, like in this case. Next slide, which I think is the last one. Oh, no. This is a nice application of our underlays. You remember I was explaining you about the light screed and light screed Tixo. This is the typical application of underlays on inside the pool trunk. We have an anti-corrosive, the application of an anti-corrosive primer like the MAPEI Guard 100, followed by the MAPEI light screed, which is applied on the bottom of the pool, while the MAPEI light screed Tixo, as I was explaining before, in this case, is used to level the unevenness of the vertical walls of the pool if necessary. In this case, the pool is a mosaic and ceramic finish pools. So after the application of the underlays, both on the bottom and on the side of the pool, the contractor applied the tiles and mosaic with our polyurethane adhesive Ultra Bond Eco Pu2K and grout with our Cerapoxy CQ. Next slide. This is just to show you same situation, same swimming pool trunk, but with a full resin system. So the first layers are always the same. So I have the application of an anti-corrosive primer followed by the MAPEI light screed applied as a self-leveling underlay on the bottom of the pool and the Tixo to level the vertical walls. In this case, instead of having glued on top the tiles or mosaic, we can complete the application with a full resin system consisting of the MAPEI design applied on the bottom of the pool and MAPEI Finish HP, which is a colored polyurethane finishing coat, which goes on the vertical walls, and all the pool then and the system is going to be closed with the application of the MAPEI Finish TS, which is our polyurethane high resistant transparent finishing coat. Next slide. Okay, now let's take a look at the internal areas. This is a typical example of a technical service room in resin. So in this case, as I mentioned before, we are going to apply the MAPEI post-grid light. It's an heavy-duty underlay, is stronger than a polyurethane because all the technical and service rooms are places where people are walking with working shoes, there are trolleys, so we need a more resistant floor. And so we have to start with the underlay, which is a heavy-duty underlay. One important characteristic also of the post-grid light, which I didn't mention before, apologize for that, is that the MAPEI post-grid light has a great compatibility with the steel deck. So really surface tolerant. So as you may see, there's no primer, meaning that after a suitable surface preparation, we can go directly and apply the MAPEI post-grid light directly on the steel. As you may see from the system as it is described, this is a full epoxy resin system, because on top of the MAPEI Screed Light, we apply the MAPEI Floor, which is a seamless 100% solid self-leveling and self-extinguished epoxy resin coating. On top of which we typically go with a two-component polyurethane colored finishing like the MAPEI Finish 100. Next one. Okay, so that's it from our side. We hope you enjoyed the presentation of today related to the underlayments that MAPEI can propose, and the solution we can propose for marine application. And we are ready if there's any question for both Mike and me.
So thank you, Guido. Thank you, Mike. I do have a couple questions that came in, so I'm going to go ahead and ask. The first question, must all products used on the ship for flooring be certified to meet IMO?
I can take that one.
Please do.
Yes, actually, all the products do need to be certified, because that international code body, the International Maritime Organization, that is actually a worldwide treaty about safety of the ships. So all of the ships, in order to maintain their insurance, for their liability insurance, they have to make sure that the products that are used when they refit or when they build the ship actually meet that code for fire safety.
Okay. Can you explain the difference between the MAPEI Marine 1000 and the MAPEI Premix?
That's an often asked question, because you say, well, why do we have a product specifically for the marine applications? Well, the MAPEI Marine 1000 was designed as a lightweight material. The MAPEI Premix was designed as a general screed mortar. It literally has double the weight that the MAPEI Marine 1000 does. Additionally, to the weight differences, the MAPEI Marine is fiber reinforced, so it's more resistant to the stresses and the flexing that happens on the ship. So the likelihood that the MAPEI Marine 1000 is going to crack will be much less.
Okay. And then one last question. Can you apply an epoxy-based underlayment over an external deck area?
I will reply on this question, Sophia. Actually, as I was explaining before, typically this is something that we have to avoid to do. All the open decks are in polyurethane resin underlay, and the polyurethane top coat is a little bit more flexible, it's a bit more elastic. People are walking with barefoot on it, especially around the pool areas, for example. Epoxy underlay is more rigid. Can it apply on the open decks? No, really not. But there is always a little exception to the rule, as we say. And for example, it happens to me to apply this kind of underlay like in the technical areas or pantries behind the bar, as I was explaining before. This is the main difference. Polyurethane, highly decorative and elastic, more for open decks. Epoxies, where the customer are not seeing it, like crew areas, and for example, back of a bar, back of or pantries are areas that are not accessible to the customers on a ship.
Thank you. So it doesn't look like there's any more questions. So that's going to conclude today's MAPEI online webinar. Thank you, Guido and Mike, for a great presentation. And thank you all very much for taking time out of your busy day to join us. We'll see you next time. So have a great day. Bye.